I am Bonnie Gurney, AMT's Director of Industry Partnerships. I have this distinct honor of introducing, the Chief Strategy Officer for Local Motors. Local Motors is a disruptive company that brings unimaginable concepts to market at unprecedented speeds. You're going to hear their story, where they're going next, and where they see the future going. I'm going to give you a little bit of background about our speaker. His name is Justin. He marries a lifelong dedication to sustainability and making a difference in the world with a background in finance and investing. Prior to joining Local Motors, he served as the Senior Portfolio Manager for Carbon War Room, which is an organization founded by Sir Richard Branson. I thought that was really cool. To incubate and scale profitability solutions to climate change. He began his career in investment banking at Goldman Sachs. He graduated with a degree in economics from Duke University and is a native of Washington, D.C., so he came all the way over from the East Coast to speak to you guys today. So please join me in welcoming Justin Fishkin to the WESTEC stage.
Can you hear me? Great. Thanks, Bonnie. And thanks, AMT SME, for having me. So I was asked to come and just tell the story of Local Motors, and before I do that, I just wanted to see how many people here know our story. Just sort of show of hands. Nobody. Oh, okay. All right. Well, all right. Great. I recognize a couple of you. So thanks for showing up to start to fill out the seats. So Local Motors was founded in 2007 by a really impressive guy who's my boss. So I have to. Oh. There we go. So I have to say that. His name is Jay Rogers. He was one of 17 grandchildren of a guy named Ralph Rogers, who you can actually see in the reflection of this vehicle. He was the president of Cummins at one point and then owned the Indian Motorcycle Company. He was the only grandchild that was interested in vehicles. And he's an impressive guy. He had the idea for Local Motors when he was in the U.S. Marines, when two of his friends got blown up in a 30-year-old vehicle. And he had this frustration, having been a student of open source software, about how long it takes to get vehicles and other complex hardware to market. And he told his general at the time, we're here fighting for oil. I have this idea, my buddies shouldn't, and many shouldn't be in this old equipment. I have this idea for an open source hardware company. And the general said, all right, I'll sign your papers. I like the idea, but you got to go to business school. And so he went to business school, went to Harvard and wrote the plan. He was the oldest student in his class and won a business plan competition there. And our first two investors were professors there. And we really hit the ground running in 2008. And what Jay understood or saw was that we've been making vehicles and by extension mass manufacturing things pretty much in the same way for about 100 years. Where Henry Ford and Gottlieb Daimler and others ushered in this era of making 1 million units or making 100,000 units on a production line. And those production lines have gotten much more efficient, but the philosophy has remained the same, is maximize efficiency of making a lot. This represents a little over 100 years of that production line, of its maturation. And if you think about it, this is about the same amount of time that we went from the telegraph to the smartphone. And so it's a bit, we're still driving on 4 wheels, primarily combustion engines. When this happened, we had electric engines, but we were never been able to scale them, or electric powertrains. And so we've really, with all the capital investment that's gone into the production line, we've really sort of hampered our progress, is what Jay's thesis was, and I would tend to agree, and I'm sure that's not lost on people here. Local Motors, you might be surprised to learn, was never founded to be an automotive company specifically. It was founded to start in automotive, just like the production line started in automotive, because it's a $2 trillion industry, where if you can have an impact, you can make a really big difference. and then that can proliferate. The reason I joined Local Motors, as Bonnie mentioned, I was at Carbon War Room, and we were focused on profitable solutions to climate change. So solving bottlenecks that weren't allowing existing technologies to scale, efficient technologies. And I was working with island nations at the time, in this case Samoa, and as you might know, island nations pay a 40% premium to import diesel for much of their, to run much of their mobility infrastructure, as well as their power in their homes, et cetera. And that makes it a lot more cost efficient today to use efficient technologies. And so I went to 5 or 6 of the big OEMs in the world and said, we need 50,000 vehicle units for this island to run on a specific type of fuel or with a specific battery size. And I got laughed out of the room 5 times. And I thought 50,000, not being an automotive guy, was a lot. And they said, we don't get out of bed for that. I mean, we can't design a vehicle for that. And funny enough, Shell, the oil company, as part of their Game Changer program, introduced me to Jay, our founder, in 2011. And Jay said, oh, this is easy. We can have the world design a vehicle because, as you'll learn, we're an open source development company. And we can build a small factory on the island, and we can employ locals to build the vehicles. And we can, over the course of 3 or 4 years, we can build those units. And I had this epiphany that the demand side of the mobility equation was the issue. If we could solve the demand side at the local level, that the supply side would follow. This is the other issue with the automotive industry that I think really, as I mentioned about Jay being in Iraq and the safety issue, even in the civilian world, this should never happen, right? You shouldn't. The most precious things in your life should not be on a vehicle like this. And when there's a lot going on in the world right now talking about autonomy in driverless vehicles, and it sounds like fanciful and sounds like you love driving, and why would you ever want an autonomous vehicle? At least that's the way I feel. But when you really look at the numbers, I mean, there's more deaths happening on the road than anywhere else. I mean, it's up there. It's up there. I mean, it's killing people every day, and it's one of the lowest hanging fruit for saving lives until we solve, cancer or heart disease. And so it's important that technology advances in order to save a lot of lives. So the fundamental thesis was, don't come out with the newest powertrain. Don't come out with new aerodynamics, which are all great things. Fundamentally change how vehicles are made. Simplify the system. And we'll talk about this in a minute. This is our first 3D printed car. You may have seen it out there. It had 50 components in it, as opposed to, let's say, 20,000 for a traditional vehicle and the supply chain associated with that. And so we went back to the drawing board as far as what the business model for Local Motors would be, and this is it. It's 2 primary components. The first is called co-creation, which means people around the world who don't work for us help us develop and design products. They're engineers, they're fabricators, they're companies, and we pay them a royalty if they use, or if we use their idea in our product. And connect that to micro-manufacturing, which means small volume production in local markets for local markets. So, co-creation. This is the world's first co-created vehicle or crowdsourced vehicle. If you look at the Wikipedia, it's called the car the internet built. And these are the roughly 7,000 people that worked on it. So the company got up and running in 2008. And in 2009, this vehicle brought to market, Rally Fighter. It took a year. And we'll talk about it in a second. This is what some of our community members look like. These are people that have designed these vehicles. The Rally Fighter was designed by Sang-Ho Kim on the top left, who is a South Korean student studying in the United States. His name goes on the side of every vehicle that gets made, and he gets paid a royalty for every vehicle that gets made. And so, this was the Rally Fighter coming together. when you think about co-creation and micromanufacturing, it's that digital thread, which we'll talk more about in a minute, that really enables it. If you can get people online around the world, and the ones and zeros can translate to a third place into a physical good, as I think you'll see here, that really makes a big difference. And this is probably the so what factor of the whole, or the really first proof point of our business, which was, it took us about 12 months to bring the Rally Fighter to market, which is about a fifth the time as it had taken OEMs to bring cars to market traditionally. We did it with about 1/100 the capital, so it cost us $3 million. And generally it costs upwards of 2, 3, we've seen now $5 billion to build a factory for a new vehicle program. And we believe the reason is because we had so many more minds working on the issue. Bill Joy, the founder of Sun Microsystems, said, whoever you are, the smartest people usually work for somebody else. We buy into that. Linus Torvald said, who founded Linux, says, with enough eyeballs, all bugs are shallow. We subscribe to that as well. And so what people usually say when they see this slide is, this isn't apples to apples, this isn't fair, this is BS, because you guys can't make 1 million units. And we spend $3 billion building a factory so we can make 1 million units. So you can't compare these things. And what we say is, bingo, that's the point. We don't need to make 1 million units. And that's what gets us into the micromanufacturing piece of our business. I like this because I think of micromanufacturing a bit like this. It's Lego pieces, it's other people's technologies that we're bringing together. And this was the first, this was the Rally Fighter microfactory in Phoenix. So a vehicle built for Phoenix, made in Phoenix, and then Lego came out with a toy. And so when we think about the traditional chain, right now it takes about 5 years if it's a new vehicle program. And what Local Motors has done is bring the third-party logistics and the dealers right into the OEM, because our microfactories are open to the public. And then we have brought the Tier 1 and Tier 2 suppliers into the microfactory as partners and co-creators. So if you come down to Knoxville, you'll see BASF in our microfactory testing composites. You'll see others like Siemens with their software in our microfactory engaging community members. So we're able to reduce our development time now to 6 months. I'll show you some of those vehicles down from a year with that very first Rally Fighter that I showed you. So, and this is what our microfactory looks like, just to give you an idea. It's about 50,000 square feet. And you walk into that gray area, that's, if you're a company or a consumer, you walk in through the same door. Our light lab is where our partners are doing testing and work, and where we engage community members on specific projects, whether they be online or physically there. And then we'll talk about how we've moved into digital manufacturing, but that's what those other two areas are. Something that's great about having a local microfactory is it enables hardware upgradability, and digital manufacturing makes that possible as well. So jump back after the Rally Fighter, 2011, 2012 was a really formidable time for Local Motors. With the Rally Fighter, the success of that, we got a call from DARPA who said, this is an interesting concept. Can you take that vehicle and can the community make it into a military relevant vehicle? And so we launched a challenge, and a guy who was unemployed, an unemployed engineer based in Detroit named Victor Garcia won that challenge. And it took us 3 months from the time that we launched to delivering this vehicle to the President of the United States. That success then led the Army to come to us, the U.S. Army Rapid Equipping Force, and say, hey, can we do this? Can we rapidly prototype out in the field? And so we set up a community to do this for the U.S. Army, and this is one of the vehicles that they brought to market. It's a paradroppable mobile command post from which you can launch drones. And this was a successful trial that's now led to doing this with the Marines, and we can talk more about that. The other thing that happened was other companies like, well, DARPA, which is not a company, but companies started coming to us and say, we've seen what you've done with open source development. Can you do this for us? And for a specific type of vehicle that an OEM might not have interest in making. The world's first pizza delivery vehicle, and has an oven in the side of it, and took a few months to win. You know, there were 5 challenges, brought this to market, just a few units. They ended up, Domino's, deciding not to go forward with us making them. And this was launched, I guess, about 18 months ago. So it took them, after we had the first units out, 4 years to bring it to market. So they paid for that decision, but we weren't as mature as a company as well. But this was another key thing that happened where we realized there were niche markets where you could solve a company like Domino's efficiency issues, where they have, from the time they take an order for a pizza to the time it's out the door, is within seconds for every pizza. I mean, they have it down to an art. But where the inefficiency for their business was coming was from door to door, because everyone has a different vehicle, and everybody, people would show up with pizza and soda that had been moved around a lot, and this was really enlightening for us to suggest that there were smaller markets that were very valuable to those who needed the vehicles because they could solve efficiency issues. The other really big thing that happened in 2012 was a partnership with Siemens. And John Miller's here today. I didn't know you'd be here. Good to see you. But he was a key part of this. And I think it really changed the CAD market, which was basically, this is, as those of you who use CAD know, it's an expensive software if you're a professional. And you could get Siemens software for the price of a pizza monthly. So retirees all of a sudden could have access to CAD. Students could have access to CAD. And I think we've seen some of the competitors in this business change their business models based on that first trial of offering our community professional tools. And so that was a really big piece of our maturation as a business. So what that enabled is our first 3D printing exploration. The Rally Fighter, we started printing the mirrors, the components of the mirror. So it was just a small initial test. But we also started, when we started integrating other technologies from partners who wanted to prove those technologies, because we could get them into our vehicles so fast. And we started seeing that there was data that these vehicles were producing that we could feed back into our process and open it up to the crowd. And so it wasn't just the data on the design side, it was the data on the operations side that could inform the design side. So this happened in 2012 with IBM and Intel and others. And then from there, we said we have to be a company. If we are who we say we are, we got to be intermodal. We got to be able to go from 4 wheels to 2 wheels. You can count on 1 or 2 hands the number of companies in the world that make motorcycles and cars. There's a reason for that. They're very different. And in that, we started 3D printing a bit more. So this was a critical part, that exhaust piece that I've pointed out there. Not as material as a full vehicle, but we started to move up into the importance of the structure and the critical parts. And then the last piece that happened in the 2012 timeframe is we said we want to be able to switch powertrains. And so we started with just an electric bike that we wanted to be able to have both run on gasoline or electric. And so all that we took on the road. We wanted to be able to be sort of like the Army, forward operating in our production. We wanted to be digital, so we wanted to be able to make things anywhere. So this Moby factory, we could make a Rally Fighter, we could make the racer motorcycle, we could make the bikes. Went out on the road. I think Buddy is in one of those. Hey, Buddy. And one of the teams we met while we were on the road was Oak Ridge National Lab and the manufacturing demonstration facility. And I was there with Jay, our CEO, and these guys are really bright guys, Lonnie Love and Craig Blue. And we saw a big 3D printer they had, a Cincinnati 3D printer, and Jay said, let's 3D print a car. And Lonnie and Craig said, well, sure, how big? This big? This big? And Jay was like, no, a full car. And the folks at AMT and SME said, that's a good idea. Why don't you do it at IMTS in 2014? And 3 months later, this was the video from that first 3D printed car at IMTS. So just like the Rally Fighter, sort of that digital thread in our partnership with Siemens shows sort of the various stages of that vehicle. Jay drove it down the street in New York a couple days later, and then I can't come to WESTEC without showing a picture of President of AMT, Doug Woods, sitting in it before we even had the decal on the side. There he is. This is how it works. So basically, you walk into a microfactory. Our first digital microfactory is down in Knoxville because that's where Oak Ridge is, and we sit about a mile away. And from there, we're commercializing various material technologies as well as machines. It starts as pellets, as it's ABS plastic infused with carbon fiber. We've since tested about 1,000 other mixes. And then there's the additive process, which is at the bottom left, so laying the material down for those of you who aren't familiar. Then the subtractive process, which is in the middle bottom, which is milling material away. And you can get various different finishes based on that. You can paint it, you can coat it. The great part of this material is it's recyclable. So in addition to being local and using digital manufacturing, the other pieces you can recycle locally, and our goal hopefully is to be able to recycle into your next vehicle. This is our microfactory in Knoxville, close to a major highway is what we do wherever we go. And sort of the vision is, as a consumer, you walk in, you decide what you want from a technology standpoint in your vehicle, we make it right there, and you drive it away. Took us 44 hours to print that first vehicle. We're down to about 20 now. So it's sort of a same day or next day type of situation. And that really enables this upgradability I'm talking about. You can bring it back to us. We can strip the technology off. We can put new technology in. This was our second 3D printed car, highway speed. That first one was, which you'll see out here, was under 40 miles an hour. This one took about 2.5 months from opening the challenge up to the world to bringing it to market, or to putting the first one on the road. Not highway certified, highway speed. This was designed by an HP employee. And we've since now opened up a partnership with HP that's been exciting. But what we found is companies really like it when their employees participate in our process, which is cool. So we can leverage knowledge from a lot of different industry leaders. This is another sort of so what slide. It's boring. Many of you may be familiar with it, but basically in traditional manufacturing, the cost curve is the curved line there, and you want to be out to the right. So if you make only a few of something, you're losing money on it. That's not where you want to be. You want to be out to the far right, where each unit you make, there's marginally less cost to make it. For us, every unit we make, theoretically, I argue the price actually comes down, but every unit we make using advanced manufacturing, using 3D printing and additive and subtractive is the same. And so it's the same price for us to make the first unit as the millionth unit. So we'll never make 1 million units. What we'll do is just make several thousand units of something. And what that's done is open up a blue sky area where it's not profitable for the OEMs to participate, but it is profitable for us. And what we're seeing is the technology companies are therefore coming to us first because we can bring it to market faster and get the foot in the door to prove to the OEMs that it works, and then they can sell into OEMs sooner. And so it's been exciting to watch that, whether it's Watson IoT technology. So OLLI, a product I'll show you in a second, is the first automotive application of Watson. Our Stratty out here was the first vehicle to have NXP's Blue Box in it for autonomous driving. We see this again and again, materials companies. And so it's a really great place to sit because of, we have pricing power, we have consumers that want forward technologies now, and we can participate as these technologies go into the OEMs. This was a graph that The Economist did following a partnership we did with GE. So Jeff Immelt called our CEO in 2014 and said, I have this issue with my appliances division. I tried to sell it last year, and I couldn't sell it. And the issue is this, that my engineer will come to me and say, it costs, I have this great idea, and it's going to cost $600,000 to develop it, and we're going to sell 6 million units the first year, and 50% of the time, he says we're going to sell 6 million units the first year, and it's going to take 6 months to develop it. And 50% of the time, what happens is it takes 12 months, and we sell 6,000 units the first year, and it costs us $20 million to develop it. The other 50% of the time, when it's profitable, the South Koreans have reverse engineered it and put better technology in it and sell it at a better price point within 6 months of me bringing it to market. And so I'm losing on both sides, is what he said. Can you help me with that? And Jay was, smart about it because we had that experience with Domino's, who we love, but who didn't make the thing, which cannibalizes our community when something doesn't get made and we tell them it's going to get made. He said, yes, we can help you, but if you build a microfactory. And Jeff said, okay. And so we launched a microfactory in 2014 in Louisville, right across the street from the campus of the University of Louisville, about a mile or two from Appliance Park, which is where GE makes the majority of their appliances. And what we were able to do in that first year was increase their commercialization speed by about 24 times. And then, as you may know, they were able to sell that appliances division to Hi-R shortly after that. But once that happened, we realized that there was a good business, platform business for us in opening up this community and our micromanufacturing process to other companies. And so Airbus then came to us, and we started doing drone work for them and drastically reduced their cost and speed. And GE and Airbus have both since become investors in Locomotors. And essentially what it is we'll brand a microfactory. We'll use our existing infrastructure to prove to them what we can do, and then we'll open up a microfactory and brand our platform, or a platform for their capability, but it's tapping into the same global community. And the interesting thing is we get paid both for doing that. On the top line, there's like almost a management or consulting fee, but also a royalty on every product that not only we make in a microfactory, but that then they take into their big factory. And so we figured out a way to actually benefit from things going to scale. So this is the result, it's called, of a challenge that we launched in 2016 or end of 2015 for urban mobility in Berlin. and it's called the OLLI. And the guy who designed it, Edgar Sarmiento, was a 24-year-old Colombian who had an idea for both a people mover and a logistics vehicle. And that's Edgar on the top left. And these are various groups of students and community members who helped us bring this to market. Took, I think, 4.5 or 5 months from the time we pressed go to put it on the road, where we launched it in Washington, D.C. with the opening of our demonstration facility there in National Harbor. We launched it June 2016. And basically, OLLI is it's a full system. So it's the front end, which is like an app. It's and the back end for fleet management, and the vehicle itself, fully configurable for the B2B or B2 government customer. And this, like the pizza delivery vehicle I talked about, has a very defined market. So it goes under 40 miles an hour, meaning it's for urban mobility or it's for closed campuses. And it's got 3 different sort of configurations, which are passenger, logistics, and other, and we'll talk about what other might be in a minute. It can, like I said, public or private roads based on the legislation and regulatory infrastructure in the market, which being local allows for. So when you hear about autonomy, it's always about like which states, what's the federal government saying. What we're seeing is different municipalities are wanting to move forward faster. So we believed that this was the way to enter the autonomous market. And then it could do open routes or fixed routes. So you can call it like an Uber in some cases if you want, or you can just use it as a circulator. And these are big markets, whether it's theme parks or college campuses or airports. When you think about it, when we have partners like Airbus and GE, I'd love it if, when I go to National Airport in DC to get here, I can get in an OLLI and GE measurement control technology can scan my body for weapons or explosives as it takes me to the airplane. Where Airbus has contracts with people who can help us with that. We're not working on that yet, but that's what people are starting to think about. Weird applications like that are technologically forward-looking is really what OLLI's all about. And we're open, because we're an open development company, open to all comers with ideas. So this is a great video of sort of the whole process I was just talking about. So have a watch. See if we can.
Are you serious? Can I have an ejector seat?
Let's do it.
I don't want to eject, but if my dad is being annoying, gone.
Right.
Chase Sapphire has sent me to discover what's next in travel. For my latest stop, I've come down to Tennessee. While I'm here, I'm going to get a 3D car printed to help me with all of my Tennessean needs. Is that a thing? I'm just waiting here. There should be someone called Ollie coming to pick me up. Ollie?
Hello, James.
Who's that?
It's me, Ollie. Please have a seat.
Right. Where's the driver?
I'm the world's first cognitive, self-driving shuttle. And I'm electric. I'm the future of travel.
Is this your only voice? Can you do any other voices? Can you do a Tennessee accent?
Hey, y'all. Who wants grits?
I mean, honestly, I don't always trust my driving. Why would I trust a computer?
Because I don't drink, text, or get tired.
So how do you flirt with other buses if you don't text?
Ha, ha, ha.
Was that your laugh? Thanks so much, Ollie. Thank you. Hello.
Hi.
How are you? I'm James.
James, I'm Jay.
Nice to see you. Hello.
Brittany.
Are you real or are you robots?
How would you know the difference?
I'll take your word for it. Let's get in there. Come on. Totally a robot. Right, Jay, Brittany, who are you and what do you do here? And bear in mind that I will believe every word you say.
I run Local Motors.
a technology company that designs and builds vehicles tailor-made to their location. We 3D print them, and then we can put in driverless technology or technology that talks with you when you're in the vehicle. The OLLI is almost fully 3D printed. The car that we're making for you is fully 3D printed.
How will I be able to customize the vehicle?
You come up with it and we will make it happen.
In the future, we could really imagine that the rental car company becomes the car maker themselves. You can get into a vehicle that's bespoke for the experience that you want to have while you're traveling. We think this method is the future of the travel industry.
So can we go now and design my car that I'm going to see in Tennessee with? I've got some ideas. I'm just saying, prepare to be blown away.
Greg here's going to help you out.
Hi, Greg. I'm James.
You're good,
How are
James.
you?
How you doing?
So I can put anything I want on this car.
Yep.
I'd like no roof. I want it convertible so I can feel the southern wind in my hair. Cruise around Tennessee, top down. What I'd love is the ability for it to become a hovercraft. Instead of a horn, it just goes, the gear shift, I'd like it to be a mold of my hand. So I'm capable at all times of holding my own hand.
Okay.
Yeah?
Yeah.
Feel it. How does that feel?
Awkward.
So this right here is the 3D printing machine that your car is actually being printed on.
Wow. So can this 3D print anything?
What do you have in mind?
Like a bathtub,
Yes?
a watch,
Yes?
a 3D printed father who says, I'm proud of the choices you've made. Do you think this is how all cars will be made one day?
I think that's the direction everybody is heading. I think we're just ahead of the curve.
Where this is you, where's the curve?
There.
There. That's not way past. You're a foot ahead of the curve.
You're
Not
right.
actually that impressive if you look at it like that.
I said, I want all vehicles to be different. 3D printing offered us a way to make a custom vehicle for a traveler that suits the needs of where they're going anywhere in the world. What do you think?
I don't know what to say, Jay, other than you're welcome. I mean, this feels great. I mean, oh, and look at that. There it is.
Look at that.
Jay, let's take this bad boy for a spin.
Hold it, James. That rental isn't free.
Oh, yeah, you're absolutely right. Can I give you my Chase Sapphire Reserve?
You know I don't have hands, right? Just pay online.
Is that okay?
Affirmative.
I'll see you around Tennessee, Ollie.
Why do the pretty ones always leave?
Oh no, I forgot a radio. I thought that was standard.
So, thanks for watching that. Two key themes to take from that. The first being that Locomotives has never spent a dollar on marketing our products, and that's what happens when you're an open company. So, like, we're not hiding what we're working on, nor are we trying to take IP from partners that we're working with. So that, Chase comes down and says, we want to feature you in a commercial, or if you saw the recent Fast and the Furious film, you saw Letty was driving a rally fighter. It was the only vehicle didn't pay to be in the movie. Same with the last Transformers movie. When the world has a part of developing and deciding on your products, the world wants to also tell everybody about your products. And so that's one key piece of this open paradigm. The other one, I hope that showed, was our microfactories are designed to make a portfolio of products for the local market, not just one thing necessarily. That first OLLI you saw was what we call our component OLLI, so about a third 3D printed, a third second degree 3D printing, meaning we printed the tooling, and a third bought off the shelf. 6 months on, we have a 75% 3D printed OLLI, and now we're able to print clear material as well. And that's essentially, additive, subtractive. And then we put it on. We use a crane to move it, and assemble it. And with the interior being totally configurable to the technology you want to use, it really enables some cool things. What we're seeing is from LiDAR to solar on the roof to sensors, in a world where the technology in the vehicles is developing at such a faster clip than an OEM's ability to bring vehicles to market, being local and being upgradable is the winning proposition. We believe that's where we're betting, so that you can bring your vehicle in, we can put new LiDAR in, we can put the latest sensors in or the latest battery technology in, and then you can be off on your way again. And now what we're seeing is, from whether it's Velodyne or LG or Samsung, all the major suppliers of technologies are really excited about a new channel to market and proving things so that they can get a foot ahead of their competition. We saw that with Watson, as I talked about earlier, where it was in OLLI, and then they were able to sell Watson into BMW very quickly after. Things I'm excited about is, and this was that other, not just logistics or passenger, well, it could be either, but what other technologies will go into OLLI? The first one I have there is a Peloton cycle, right? Like, could it be a mobile gym that picks you up? The second is a nugget ice maker that we did with GE at First Build. Could it be a mobile bar or juice dispensary or a mobile coffee shop? Both of those three middle things are things we did with GE, or a pizza delivery vehicle or food truck that you order. I mean, what if you order your Starbucks and it comes to you? And then the last one, we've been testing a lot of drone technology. Should it be able to launch drones for traffic purposes for the city or whatever it happens to be? If you'll see over here, we're working on that with both the Strati and the OLLI. Basically, it's for traffic and determining best routes and stuff. And this is really just stuff that we're doing for fun. We partnered with Mauser on that particular project, Mauser Electronics, and it was opened it up to the world and got some really great thinking behind it. And you'll see, like, that's a very crude dashboard up there, but something we can do very fast with whatever technology is of the moment for the particular task at hand. And so that was just an exciting, fun project. I'm not saying that's the future of anything necessarily. And then, of course, and I only got a couple more slides, and I think we're opening up for questions. This is the OLLI's a B2B sale. It's our first product with global demand. So we have thousands of units that have been of interest. We never had that before, and that poses a new challenge for us because we have to choose where we're going to be local. And these are some of the things that customers, whether it's governments or companies, are coming to us asking for from an application standpoint. One I'm most excited about is the ADA, so folks with disabilities, and making it the world's most accessible vehicle. And we recently launched a challenge for that with the CTA Foundation and IBM, where we're hoping that it's going to be the all-access vehicle, meaning if you have a cognitive disability, it'll know that, and it'll help you accordingly. If you're blind or deaf, same thing. And with Watson, there's some really exciting steps we've taken, and you'll see this accessible OLLI launched at CES if you'll be there. But it's the one that I'm most psyched about. So if you have ideas, please submit them online. And that's my presentation. I know we talked about, I jumped all over the place today, so I hope at least some of it was coherent and had a consistent line. But I'm around, and I'm happy to talk to anybody that has questions beyond just this question session. And so thanks for listening.
Thanks, Justin. We do have a microphone. If anybody has any questions?
I don't think it worked, your microphone. Yeah,
nope.
We have
any
microphone.
Questions? All right, we're good. Well, I just want to thank...
Yeah, there's one.
Oh, we got one. All right. Oh,
Yeah.
You have two questions. Okay. The microphone's coming. If you want to hold on 1 second, sorry. No, I can't hear you.
You got a question? Hi.
Hi.
So how the repair and overhaul of your vehicle plays a role in your business model? Since I saw, at least for the customized vehicles, it appears that it's like a mono part. And if I crash my car, it's probably I need to buy another one, or how do you deal with that?
So the question is, I heard multiple questions. Sorry, what you're saying? How do you deal with a crash?
Yeah, for example.
So we chop up the material and we can recycle it into a new print. And so it really depends on the specific crash as to whether we would just make you a new body right there, if it's catastrophic or repairable. You got to think of a crash as very different than in a traditional vehicle, because this is a new material, and we're seeing new types of issues. But it's pretty inexpensive for us to just make you a new body, I guess, is the simple answer for that. I don't want to get too focused though on consumer vehicles, in that you can't drive so. We have low-speed electric vehicles right now for sale to consumers, and so they aren't going at high speed and aren't seeing catastrophic crashes, and we're getting urban mobility sales for those, or customers for those. So we're not any other than the Rally Fighter. So the Rally Fighter is the really cool-looking car you can see down there. Buddy Crisp is here. That was our only highway vehicle that you can buy today, and that's not 3D printed.
Any others?
Questions?
Just wondering about engine and bearings and mechanical parts. How can you possibly 3D print those, or do you?
We don't. So essentially, we're a rapid integrator of other technologies.
So you would buy a standard type of engine or a wheel bearing and put that in your 3D.
Yep. So we're buying. When I talk, maybe it's a misnomer, but I believe it's when I talk about technology partners, I'm thinking of powertrain providers as much as AI providers. So yes, we're buying. We're not. We've met some companies that are trying, as I'm sure you have, that are printing or trying to print the pieces of the like a powertrain, let's say, or a people are working on battery stuff. But no, we have partners that we're bringing those in and integrating them, and that's what allows us. So we're essentially printing the body. If you think of a body in a chassis, traditionally that's one unibody now, and then we're just putting the technology in or stripping it off.
Makes sense.
And we can print to the technology, right? So essentially, if there's a different form factor, we're printing around it. And we can change that rapidly.
Any others? Good. I think Justin will be here for a few minutes if you want to talk to him a little bit. And then we've got the Stratty on the other side of the wall. So if you want to go touch it and see it, it's over there. And then I just want to present you with a speaker. Thank you.
That's cool.
WESTEC,
Yeah, thank you. Awesome. Thanks for listening.